Today we will see the sequence structure and other programming. Come to your PC, make a new folder, day 17. Make a new folder, day 17, and open your LabVIEW. Open a new VI. Right click, press Ctrl T. By pressing Ctrl T, we can align our LabVIEW left and right. In front panel, we found the control palette, and in block diagram, we find a block. We found a function palette. Suppose here, if I am writing, suppose here, if I am writing a program here, okay, any small program for, okay, and I want to put end of that two number, I am putting here. So here, after that, after end of this number, if I want to run my for loop, as a result here, sorry, not for loop, because it will be not, yeah, and just a second, indicator, okay. Now you can see here, after that, if I will take one more function, that is OR function, and I will try to connect with the OR function with this. I am not getting the any good example right now. Sorry for the this problem. Okay, I don't know why. I hope my mind is not working today. So it will give you the AND output, and it will be give you the OR output and an OR output. If I will try to write this program, so both program will execute at the same time. I want this program should execute after this. I cannot channelize anything here. I cannot channelize anything here. I cannot give any wait time here. There is one beautiful program, okay, the function, and that is split sequence function. In this split sequence, using this split sequence, first I can read any data. In this first sequence, I can read any data. Sorry, in this yes, I can generate any data. After that, just a second. Yeah, using this flash sequence, I can first perform here one function. Then I can add one more, and here I can give another command, and using this I can give the another command. In this way, forcefully I can control, okay, my functions one by one. Okay, I'm getting the examples now properly. Okay, suppose there is one function, there is one program, okay, there is one program, uh suppose sign, right click, come to the express, simulate signal. It is an individual program, and using this program I can only acquire the data. I can only read the data. Okay. After that, I want to display a dialog box. I want to display a dialog box which I want to measure the high temperature, high temp. Then after that, I want to run same program, okay, to change my signal because temperature was high. I want to change, sorry, I want to change the program to generate control Z, control. And also I want normal temperature. When I want to start this program, I want to run the first this data, then I want to execute this one, then I want to execute this one, and then I want to execute this one. But if I will run this program, so all the program will run simultaneously, and I will get, okay, all the program will run simultaneously, and I cannot do anything. All the programs are running simultaneously. Okay, I am not able to control. So what is the best way to control? What is the best way to control, okay, the order of execution? So here the order of execution I can control by using this flat sequence. Using this flat sequence, I can forcefully use, I can first use this program here for a specific time. Then I can give this program here, I can give this program to wait for 1 second. After that, again I can give this thing here. Then I can come here. After that, I can stop my while loop. Okay. From here, I can stop my while loop if the data is correct. Control B. If my data is correct, then or so I can connect from stop my while loop. Either I can stop from here. Now forcefully you can see. Okay, and here create constant. Small one is okay. Fan on. If I will press it, fan on. So I am expecting my this loop. I will get this data. Okay. Now here I can put here stop. Either I can go further, run again. Getting my point? Let's try to run the program. Okay. Let's try to check here what I'm getting. Okay. Because here it's waiting for the another's data. What it will be. So here I am able to execute control, but here I am not able to control the order of execution. Run. run. Now you can see here, first this loop is executing. Okay. Hmm. Stop. Again run. Turn off, turn on. It's false. Okay. Run. It's false. Again it will run. Now I cannot stop. Now I can stop. Now you can see I am easily able to control the execution loop, but here I am not able to find my targets. Here I am not able to find my targets. What is my target? My target is here. If I want to just, okay, cut down I want, if I will met with one certain uh, effect, I want to cut down and I want to stop the program. But here, using the sequence structure, I cannot perform. Yeah, using the sequence structure, easily I can break down and I can control the order of execution. That is true. Here I am going to save this program. When we will discuss about the event structure, at that time I will give you the proper solution about this program. How can we control it? Okay, how can we control it? Either, either you can do one more thing. Stop. Okay. Uh, yes. Hmm. Here I am going to create one stop functions. Stop program. Look at here. I'm going to create a stop program. Okay. Now it is my stop program which I can connect here. Control B. But I don't want to. Okay, which I can connect here. So here, or replace this one. Control B. Come into this compound arithmetic. I think it is a OR function. Great. Make a connection like this. Let's say we are able to find our target or not. Here I am going to create. Here I am going to create my local variable. Local variable is just like a local variable. Yeah, I'm going to create a local variable. But local variable is just like a program, not data recursion. It is just like a pointer. Local variable will give you a memory element where you can store your data. Memory element where you can store your data. Can I create? Let's come here and try to create a local variable. This local variable is a this local variable. Okay, will create using this local variable. I can create a pointer. I can create a location where I can store my data. If I will try to use this local variable, so can I try to solve this function? After pressing yes, this stop should update automatically. Yes. And here I don't want to use this one. Control B. And here also I don't want. Okay, don't want to use this one. Let's see. I am putting local variable in a two location, here and here. Let's try to break the program and try to write the code. Clear? But if I will run the program here, so I will get to know local variable action is latch action. I need to change the local variable action into the Boolean action. So for that, right click into the stop functions, come into the mechanical action and change it to the switch action. Now my local variable will work, okay, very well. So now my local variable will work effectively. If I will try to run the program, so what data I will get, how it will work. Right click, frequency, I am going to give the constant frequency 100, sorry 10, let's give the frequency 10, okay, and same frequency I want to put here 10. Come here, run the program. No, here we are also not able to find out, because if I will pass the stop button, so it's updating the stop button. But again, after that, here, if I will update the stop button, so now you can see it's updating the stop button. Still, it is passing the data with this loop. It's passing the data with this loop. Okay. So here we cannot control any. We can control only order of execution. If you want to control order of execution, so the sequence structure is must. You can control the order of execution. Okay, sorry, you can fix the order of execution from left to right. Getting my point, sir? But programmatically, if you want to control the order of execution, so for that we need to understand about the state machine algorithm. State machine algorithm. Maybe tomorrow I will explain again. Let's come into the new another program where you will able to understand the logic. Might be the example will be more clear for you. Hmm. Here I am using while loop. Now here I am using right click, come here. Okay. Express BI signal. Okay, frequency 10.1. Okay, 100. Automatic 100. Clear. Here I am going to use create indicator. Create indicator. Now I want to stop the program. Let's remove it. Remove this loop. Okay, first. Now, if I will run the program, so I will get a proper signal, sinusoidal signal here I am getting. Clear, sir? But if I will run the program again, so I will get the sinusoidal signal again. Here I am not able to clear my program, not able to clear my signal. Let's take a split sequence here. Right click, add before it, and here right click. I think my brain is totally not working today. I am not getting the proper example. Okay, but no worry. Okay, right click here, come into the create, come into the property node, invoke node here, the invoke node. Hmm. Property node, and hmm, let's say let's take the data. Okay, just take right click, create local variable, and place here. right click, okay, create constant, right click, create constant, okay. uh Here, just a second, control B, control B, just a second. I'm clear the graph. Okay, right click, come here, come into the local variable, place here, create a constant. Now run the program. If you, okay, then always you will find first this graph will clear your program, and it will give you 100 seconds to watch. Okay, if you will 100 sorry millisecond to watch. Now 1 second it will be empty, then you will get the data. In this way you can execute this order, and you can easily able to, okay, you can use and you can control the order of execution. Because if you will put, if you will remove this sequence structure, so everybody will work independently, everybody will work independently. After executing, program is taking the 100-second delay. Suppose if I will put here this thing, still it will take 100-second delay to update the program. If you put here, still it will take 100-second delay to control the program. But as earlier concerned, if you'll put a case structure, sorry, a local variable, sorry, this sequence structure, so you can first it will clear, it will wait for some second, then it will update, and after updating the program, it will clear the program. Hmm. If you want to check here, I'm going to create it to create constant. True. In place of that, here, in place of this, I'm going to use one beautiful logic. Definitely you will like that logic. Let's take here outside. Mhm. Okay, okay. Now here I'm going to create add shift register. Previous data, do you want to call previous data? Yes, so I want, or do you want to clear the value? So here, let's take this one, this sine waveform, delete this one, right click, sorry, right click, come here, create local variable, put here, okay. Do you want to clear the data? If no, then come good. If I want to clear the data waveform chart, so definitely, okay, and it will take time. Now, right click, create a extra frame and put the comment here. clear, clear. Yes. And no. Yes. Clear. No. Getting, sir?
So, sir, we are trying to take user input whether the program should clear or continue.
No, sir.
No, sir.
We
We
we want to here control the order of execution. Just we want to maintain the flow. First, this program should run, then this program should run, then this program should run.
Okay. So, like statements, we have one after the other. If so and so happens, then so and so,
Yeah,
else
yeah.
so and so, like that.
Okay. Either if I will leave all the programs, so they will behave like in a scattered manner. Okay, sir. Now look at here. Here I am taking one program while loop, and here I am taking one more program. Sorry, just I will try to copy and paste. Just a second. Give me a moment only, sir. Okay. Here I am taking this function. Right click, come into the measurement. Uh, mathematics, elementary, trigonometry. Sorry, elementary, trigonometry, sine and cos, both the signal. Here I am taking divide functions, which will divide my value, my number, and it will generate two signal divided by the constant value 10. Control A, Control U, right. Now you can see here, it's my function. Now, here I am taking one waveform chart. Right click, okay, come here, take a bundle, right click, take two signal here and plot. Control A, Control U. And let's try to write a code, create stop, timing 50 millisecond or 100 second, okay, 50 millisecond delay. Run the program. Now you can see here, we are able to generate two signal and we are easily able to stop two program simultaneously. If I will use this program here, if I will use the same program one more time, one after the other. Okay, because just because of that this uh, here I'm going to delete. Suppose both are the one after the other same program, and here I'm going to connect with this. Getting my point? Now I am passing the data through the wire. Now I'm passing the data through the wire. Now please tell me, can I able to run the both the programs simultaneously?
Yes, both will run simultaneously.
Okay. Now I think it's visible to you both. Okay. And here. Can I run both the programs simultaneously?
No, sir, it will be stuck in the first loop.
Only the first program will run.
Yeah.
Second program will not update.
Will never come. Yes, yes.
If I will stop the program, so only then second loop will run only once. Again, when I will run the program, so first loop will run continuously, and after pressing my stop button, the second program will run only once and it will stop. Why? You have to recall the particular concept here, how the loop behaves. This loop will run continuously till it will not get any command, till it will not get any true command. When it will accept a true command, the loop will stop the execution. But there is one more concept working here. This loop will not execute till the condition terminal will not get a appropriate output. Suppose, okay, in this condition, you will see, in this condition, you can see here, the second loop is waiting for his command. Here, condition terminal is waiting for the particular command. If the when the second loop will get the particular command, then only the loop will work. Now, when you will press the stop button, it's generate the stop, and after that it's close. Okay, and after getting the true, it will get the true condition. Just because the function is added with that uh, do while loop, that function has a do while loop property. That's why this function will execute only once to check the particular order of particular command. That's why it get this particular function will run only once. Now let's make some more magic. Put the signal here. In that case, can I able to run both the loops simultaneously? Yes, I can run both the loops simultaneously, but I cannot stop both the loops both the loop. I can run both the loop, but I cannot stop. I am not using here run continuously. Still, I cannot stop. Why? Because here again, our that basic functionality, basic concept is working. When you will okay, look at here. When you will generate, so first it is providing one condition, and that condition is false. After taking this false condition, loop will check the condition is getting the false value. That's why loop is running continuously. Okay, and here we know very well during okay, using whenever we use for loop and while loop. So if our controller is present outside from our for and while loop, if our controller is present outside from our for and while loop, so uh, at that time if we will run present out of the while loop, and if we'll run the program, and after running the program, if we will change anything using this controller, so that will not affect our while loop, we are able to see the same effect. Here we are doing and it's generating the true and false value, but system not considering that true value. Why? Because that is present outside. So in this both the cases we cannot able to connect. Okay, we cannot. What can I say? Yeah, we cannot start both the loops simultaneously, and we cannot stop both the loops simultaneously using this polling methodology or using this wiring program. So there is a one concept which I can use here, that is a control B. And there is very beautiful concept, and that concept name is local variable, which I can use. Right click, come to the create, and come into local variable. Using this local variable, I can make a memory, and whatever the data, it will feed to the memory that will reflect at the same time, and we can read it. But here one more problem. Right click, and we need to change, it is read type, so right click, change it to read. Now, okay, local variable. After that, after that, here I am getting the error. That means because local variable latch action is incompatible here. If you read, so you first local variable change into the your switch mechanical action. Right click, mechanical action, switch when pressed. Copy here, then again right click, come here. Okay, now run the program. In this way, we can run both the program and we can stop both the program. But now you can see we can run both the program. Now we can stop both the program. And in the next time, you can see here it's running only once. Why? Why? Because earlier in the last stage, we have switched it into the true. That's why it's generating the true continuously. That's why both the loop will run only once. So every time manually you need to refresh it and you have to run. Now to remove this problem, right click, come here, create a local variable and create constant value, make a connection like this, false. Run the program. Every time first it will clear the status. So we call it initializing. We call it initializing. Here we are initializing these things. Here we are initializing the particular section. Okay, we are initializing the particular section. Now here, if I will take the local variable, local variable of this, okay, and let's take a create constant, create constant waveform chart. If I will take the same, sorry, control Z, create a local variable, can I able to achieve the particular solutions which I want to do? No, it's adding zero value here, but we are not able to clear the chart. We are not able to clear the chart. Right click, if I will come here in invoke node, initialize to default. Initialize to default function here. Are you able to see the initialize to default? Right click, come here, initialize to default. Here I'm taking. So here, are we able to get the particular solution? No. Definitely we are able to find out, we are able to get the particular solution where we are able to clear this waveform. Okay. but we are not able to create the. Now here I am going to clear the data first. And now here I am going to clear the data. Now run the program. Stop. So it's not working here. Waveform chart initialization, reinitialization is not working. So there is any other data? Okay. No, it will not work. Clearly. This other option. Mhm. Hmm. Right click. Come here. There's any other local variable which we cannot able to use, invoke we cannot use. There's any here things. History data. Are you able to see the history data? History data. Take the history data here. Change it to the read type. Okay. Then let's try to create constant. Create constant. Right click. Come here. Property nodes. Tomorrow or day after tomorrow we'll do the work on the property node. Right click. Change to all. History data. Run. Yeah. Now you are able to achieve the particular solutions. Now here, first remove this one. Control U. Right click. Come here. Add frame after. I don't want to use this one. Right click. Create. Add frame. Okay. Invoke node. Export to Excel and export to Excel. Export to Excel. Right click. Come here. Invoke node. Export to Excel. Let's try to run the program. Run. Stop. Are we are getting the Excel or not? Yeah. Here we are getting the Excel. We're able to export the data. Okay. Then practice all these things. I'm going to update it. Okay. And tomorrow we'll work on the first some cluster. Then uh, tomorrow we'll work on the event structure. We will start event structure tomorrow. Yes. If you want, so we can work on a machine state machine. If if you want, so we can work on the machine learning also. And here I had introduced you the particular